Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 12.1 entitled Functions Involving Square Roots. And today we're going to find the domain and range of square root functions, and then we're going to make a table of values so that we can graph the square root functions. And we've talked about square roots earlier in the year. We talked about them a lot in chapter 9. And remember that a square root function is a graphable equation where the variable is inside the square root. So we've talked about the radical, and we've talked about the stuff inside the radical. That's called the radicand. And now it's just going to be set equal to y. So it'll be an equation or a function, a graphable equation. And we're going to have to evaluate these functions for a given value, so that way we can find their domain and range and then graph them. So before we actually start graphing them, let's just review a little bit as to how you actually evaluate a function. And here we're going to evaluate the square root function for the given value of x. Now the way this is written is sometimes a little confusing because you're given your function, y equals, in this case, the square root of 4 times x. And then after this semicolon, this is the value that they want you to substitute in for x. So that's just the way it's written in the textbook. So that means we'll take 9 and we're going to substitute it into the square root equation for the variable for x. So now 4 times 9, that's going to be 36. And the square root of 36 is 6. Now we're going to assume that we just want the positive value here. Don't know why it was jumping around like that. Okay, so we're just going to assume that we want the positive value here for our y value. So then this would actually be an ordered pair. If we put in x, which is 9, we get out y, which is 6. So that will be an ordered pair that we can graph on the graph of that function. Okay, so let's try part B. Here our function is y equals 5 times the square root of x minus 10. And then 14 is the value that we're going to substitute in for x. So we'll have 5 times the square root of 14 minus 10. And 14 minus 10, that's 4. And the square root of 4 is 2. And there's multiplication going on between the 5 and the radical. So 5 times 2 is 10. So that's the value for y when x is 14. So again, that would be an ordered pair that we could graph for that square root function. And for the last two here I have my function y equals the square root of 2x plus 7, and then the value that we're going to substitute in is 21. So we'll have the square root of 2, I don't know why it jumps around like that, sorry, 2 times 21, and I'm just going to put that in parentheses when I substitute it in. So now I have to do 2 times 21, so that's going to be 42, plus 7, and 42 plus 7 will be 49, and the square root of 49 is 7. So again, the ordered pair 21, 7 would be a value on that square root function. And then the last one here, just to practice, this one's a little bit different because we don't have more complicated stuff inside the radical like we did here in part C. We had 2 times x, then we had to add. Here we have stuff going on outside the square root, or outside the radical. So our function is y equals the square root of x, and then we do the plus 4. It's not the square root of x plus 4, because the plus 4 isn't underneath that little bar for the square root. So negative 2 is going to be the value that we're going to substitute in. Now actually there's two parts that are going on in this problem. We've got the square root of negative 2 plus 4. Now if this had been the square root of 9, we could have taken the square root of 9, which is 3, and we could have added the 4 to it, and we could have gotten an actual value. Okay? So we wanted to try and simplify that square root first. So that would have been another way that the problem could have worked out. But here they gave us a negative value to substitute in for our radical. And remember back to chapter 9, we can't take the square root of a negative number. It's no real solution. So we don't actually have to worry about adding this 4 or not. But it's a good point to make sure that we know that if this had been a number that we could take the square root of, then we would take the square root of that number and add 4 to it afterwards. Okay, so now that we've practiced that a little bit, let's take a look at these 3 examples here, part A, B, and C for example 2. And we're still going to use that skill of doing substitution so that we can make a table of values, so that we can graph functions. Now we're going to practice making the table of values first before we actually graph them. And there's actually a little trick that we can do to make sure that we are picking the correct values for our table of values. And it's by finding the domain of the function. Now the domain is all of the x values that you can put into the function. And there's only so many numbers that you can take the square root of. Like we saw in that previous example, you can't take the square root of a negative number. So your square root has to be 0 or a positive number. So to make sure that we have a number for x that's going to give us a square root of a number that's 0 or positive, we're going to make sure that our value inside the square root, that radicand, is going to be, I'll write it up here, make sure that your radicand is going to be greater than or equal to 0. Always. We always want the stuff that's inside the square root to be greater than or equal to 0, because we can take the square root of 0, and all the stuff greater than 0 is a positive number, and we can take the square root of that. Even if it's not a perfect square, we could still type it into our calculator and get a decimal and graph that decimal. So we can take the square root of 0, which is 0. We could take the square root of 4, which is 2. Or we could take the square root of 2, which is 1.41. So we want our stuff inside the square root to always be greater than or equal to 0. So that way we can take the square root of it, because we can't take the square root of a negative number. That's not allowed. So for these problems, before I even start making my table of values, I'm eventually going to have a table of values here, but I want to know which numbers I should pick for x so that I'm going to get a value that's greater than or equal to 0. So I'm going to take the stuff inside my square root, that radicand, and I'm going to set it greater than or equal to 0. Now in this case, the only thing I have inside the square root is an x. So that's pretty easy. I'm going to pick 0 and then a bunch of numbers greater than it. And I'm going to pick 1, 2, 3, and 4. Now I'm just picking these to start with. In a moment I'll show you how we can pick smarter numbers, so that way we don't have to deal with decimals. But here we'll get the square root of 0 is 0, the square root of 1 is 1, the square root of 2 is 1.41, the square root of 3 is 1.73, the square root of 4 is 2. Okay? So making sure that I do my domain first then helps me ensure that I get numbers in my table of values that are actually able to have the square root of them taken, that we can take the square root of them. Now once I have my domain, then I can actually figure out what my range is too. Remember, range is all of your y values. So if I look in my table of values here, all of these numbers are greater than or equal to 0. I start with 0 and then I go up from there. So if I wanted to, I could say that my range is all of the y's that are greater than or equal to 0. So those are two important concepts and skills that we've been talking about in the past. We've talked about domain and range in the past, but this is why we talk about them, because they help us make our table of values. So again, for part B, the first thing I'm going to do is I'm going to find my domain. And to do that, I have to set the radicand greater than or equal to 0. So here I have y equals 7 times the square root of x. This x is the only thing that's inside my radical. So I'm going to set it greater than or equal to 0. So again, like part A, I'm going to start my table of values with 0. Then I want to pick numbers that I know I can take the square root of. So I'm going to pick numbers greater than 0, because I have to be greater than 0, that I know I can take the square root of. So 1, and I could pick 2 or 3, but that's going to give me decimals. So 4 is my next perfect square. I could do 9 if I wanted another number. Okay, so now I substitute these in. So the square root of 0 is 0, and then I multiply it by 7. So that's also 0. The square root of 1 is 1, times 7 is 7. The square root of 4 is 2, times 7 is 14. The square root of 9 is 3. 3 times 7 is 21. So there's the table of values that would help me graph that function. And then if I talk about my range, which is all my y values, notice that I start at 0, and then they all get bigger. So again, I would want all the values greater than or equal to 0. Now, it won't always be that you have a domain and range where everything's always greater than or equal to 0. That's just the examples we've done so far because we've substituted variables in for just the square root of x, or values in for just the square root of x. But in part C, here, now we have a little bit more inside our radical. We have a more complicated radicand. We have x plus 1. So again, I'm going to start by finding my domain. And to do that, I set the radicand greater than or equal to 0. So the radicand this time is x plus 1. And that has to be set greater than or equal to 0. And now if I solve this, I'll get x has to be greater than or equal to negative 1. So that is going to be my domain. So when I make my table of values, I want to start at negative 1. Now when I substitute negative 1 in there, negative 1 plus 0 gets me 0. And the square root of 0 is 0. So we have to be a little bit smarter here when we're picking our values. So if I wanted my next perfect square to be 1, I would have to pick 0 to substitute in here for x, because 0 plus 1 is 1, and the square root of 1 is 1. Okay, my next perfect square would be 4, so that means I would need a 3, because 3 plus 1 is 4, and the square root of 4 is 2. Okay, let's do one more. My next perfect square after 4 would be 9, like I had over here. And 8 plus 1 gets me 9. So 8 plus 1 is 9. The square root of 9 is 3. So you can still pick nice whole numbers here. And if you can't think of that process, then just pick some decimals, or pick numbers that might give you decimals when you take the square root of them. So I could have picked negative 1 and 0, and then 1 and 2 and 3 and 4, 5, 6, 7, then 8, 9, 10, 11, 12, and so on. Okay? You can also put this into a graphing calculator if you want. You can go to y equals and type in the square root of x plus 1, and it will give you a table of values. And you can look at the table and just write down the whole numbers. Now, the nice thing about the graphing calculator is that if there's any value, any domain value, that doesn't give you a number that's greater than or equal to negative 1, then it will say error. So you know not to pick that value. And we also have to write down our range before we're completely done with this problem. And again, the range is all my y values. So I'm going to look at this beginning value up here. My domain was negative 1, so this is my first value for my range. It's 0. And then I have other numbers below it that are greater than 0. So I'm going to write y is greater than or equal to 0. Now again, this is just how these first examples were, that all my ranges were greater than or equal to 0. That won't always happen. It just depends on the problem that you're given. Okay, so those are the steps now that we're going to do for example 3. This is our last example. We've got 2 parts to it. Here they want us to find the domain of the function, make a table of values, graph it, and then write down the range. So we're going to do exactly what we did in example 2, except now we're going to actually plot the points and see what the square root functions actually look like. So to begin again, I have to look at the stuff that's inside my radical. I have to look at the radicand. Now here, again, this is like what we talked about in example 1, where it's just the x that's inside the radical. This minus 1 is outside the radical. It's not underneath that little bar that goes across the top. So I'm going to, for my domain, just take x and set it greater than or equal to 0. And then I'll be able to start my table of values there. And I'll make the table of values up here. So I'm going to start at 0. And then I'm going to pick other numbers that I know I can take the square root of, like 1 or 4 or 9. Those are all perfect squares. And since x is the only thing inside the radical, I just want those numbers. So the square root of 0 is 0, and then I subtract 1. The square root of 1 is 1, and then I subtract 1 and get 0. The square root of 4 is 2, and then I subtract 1 and get 1. The square root of 9 is 3, and then I subtract 1 and get 2. So now I had just said at the end of example 2 that you won't always have a range that is equal to 0. And here we don't have that. Okay, my domain was 0, so this is my first value for my range here, this -1. And everything gets bigger than -1 as I look down the rest of the table. So my range value is going to be all the y's greater than or equal to -1. So now those will be the values that I'm going to plot. So I'm going to start at 0, -1, and then 1, 0, and then 4, 1, 2, 3, 4, 1, and then 9, 2. So here's my square root function. It looks kind of like a little curve. It's kind of like half of a parabola that's laying on its side. And actually, if you want to graph a parabola that does open on its side, this is what you're graphing. You're graphing two square root functions. But you'll talk more about that when you get to Algebra 2. Okay, so let's go through these steps again just to practice for Part B. Again, I'm going to take a look at my radicand. That's all the stuff that's inside my square root. Wow, this is the most complicated thing that we have seen so far. Okay, so for my domain, I'm going to take the 3x minus 10, and I'm going to set it greater than or equal to 0. Remember, it's always greater than or equal to, and it's always 0. And then I have to solve this for x, so I know the very first value that I'm going to put into my table of values. So I have to add the 10 over. So 3x is greater than or equal to 10, and then divide by 3. So x is greater than or equal to 10/3. So that's kind of yucky. If we wrote that as a decimal, it's 3.33. So you could think of it either way. You could write 10/3 or you could write 3.3. But now if I put 10/3 back in here, 10/3 times 3, the thirds and the 3 would cancel, so I would just get 10. And then 10 minus 10 is 0, and the square root of 0 is 0. Now, I picked numbers that, oh, well, for this domain, I picked a number that was a fraction because I had to. Either this fraction or this decimal. This has to be the first number in my table of values. But then I can pick any number I want to after that. So I could pick whole numbers for x that will get me a nice perfect square, but that's going to be kind of challenging. That's going to be really hard to do. It wouldn't be so bad if it was just x minus 10, or maybe just 3x, but when you have an expression like this where you have to multiply and subtract, that's really challenging to find a nice even number that gives you a whole number for an answer. So this is also a good example where it shows us that we can just pick some bigger numbers as we go through our x values here. So the number that I started with was 10/3 or 3.3. And I have to be greater than that, so then my next whole number after that would be 4, and then 5, and then 6. So this is another good example where I'm going to get some decimals for my values for y, but that's okay. You can graph decimals. So if I substitute in the 4, 3 times 4 is 12, minus 10 is 2, and the square root of 2 is 1.41. If I substitute in the 5, 3 times 5 is 15, minus 10 is 5, and then the square root of 5 is 2.24. And then 3 times 6, that's 18. 18 minus 10 is the square root of 8, which is 2.83. So then when I plot these points, remember that this 10 thirds is like 3.33, so it's 3 and a third. So I'm going to go to 1, 2, 3 and a third, a little bit more, and then up 0. So right about there is where I'm starting. Then I'm going to go to 4 and 1.4, so almost 1.5. And then 5, 2.24, so just kind of estimate a little bit more than 2. And then 6, 2.83, that's almost to the top. So this curve starts to get really big really fast. It's a lot taller than the one we did before. And then remember that the last value I need to write down is my range. And again, I want to look at this first value for my y. So I know that the y values have to be 0. And then I look at my table of values. I look at all the other values after the 0, and they all get bigger. So I'm going to do greater than or equal to that first value. So for these problems, start with your domain, make your table of values, graph it, and then you can write down your range. You could write down the range before you graphed, okay? But the domain is the values that you pick for your x's, and the range is the values that you get out for your y's. And it's all going to start with the first ordered pair in your table of values. Notice that this first ordered pair here was 3.30. And the 3.3 was my x, and then the 0 was my y for the domain and the range. So you'll get the actual values. You just need to worry about what sign it is, if it's greater than or equal to. And notice that most of these that we've done are greater than or equal to. But you could have less than or equal to too, depending on the way that the square root function is moving. Here they were moving up and to the right. We can also have ones that, when we graph them, they go down and to the right, or we can have ones that go up and to the left. We can have ones that go down and to the left. So we can have lots of other different directions that these graphs can go, but most of ours are going to go up and to the right. So again, use that first value in your table of values to tell you what your domain and your range values are going to be. And then you just have to worry about the sign. And to determine the sign, you look at the values that come next in your table of values, picking values greater than 0 and greater than -1. So it's meant to be easy, but it's higher level thinking. And that's why we need to practice these problems, so that we get really good at graphing and we get really good at understanding the domain and the range. So work through these problems, and if you have questions, come on in and see me before school.